Good day, grade 9s. I'm Miss Babo and welcome to the Physical Sciences part of Natural Sciences. Today's lesson, we will be doing a bit of revision and learning about compounds. In this section, we are going to do revision on the periodic table that was completed in grade 8, and we are going to teach you about compounds, making compounds, and naming compounds. Let's start with the periodic table. Firstly, what is the periodic table? It is a table of chemical elements that are arranged with elements with similar atomic structures and characteristics that are grouped together. In the periodic table, there are rows which are horizontal and columns which are vertical. Each block found on the periodic table can give you the following information. In each tile or each block, there will be the chemical symbol representing the element, the atomic number, which shows us the number of electrons and protons, and we have the mass number. How we use the periodic table: each block or tile will give us the symbol. On top of the symbol is the atomic number. Now, the atomic number will always be the same number of protons as they are electrons. The reason for this is because on the periodic table, it shows us the atomic information of a neutral atom. Neutral meaning there will be the same number of positive charges, which are protons, as the negative charges, which are electrons. The mass number will always be the slightly larger number on the periodic table. The mass number will show us the amount of neutrons if we have the mass number minus the atomic number. Remember, in an atomic structure, the electrons orbit around the nucleus, and within the nucleus, the protons and the neutrons can be found. Now, there is quite a bit of information we are able to obtain from the periodic table. Let's start with the groups. They are the vertical columns on the periodic table. All the elements in the same group have the same number of electrons in the outermost energy level. Those are called valence electrons. Elements of the same group will have similar physical and chemical properties, but there are 4 groups that have specific names which you must remember. Group 1 on the periodic table is the alkali metals, which is this group over here. Group 2 is known as the alkali earth metals, which is next to group 1. Then on the other side of the periodic table, we have group 7, which is this group over here, and they are known as halogens, and group 8, which is the last group over here, are known as noble gases. With regards to periods, periods are the horizontal rows of the periodic table. All the elements in the same period have the same number of energy levels for the electrons. If you have a look at this diagram over here, this inner red circle is the nucleus, and all the circles surrounding them are our energy levels with the electrons in that are orbiting around the nucleus. So to sum it all up here, on our periodic table, the black arrows represent the periods and the blue arrows represent the groups, starting with alkali metals, alkali earth metals, halogens, and noble gases. With regards to metals and nonmetals, if we were to have a look at our periodic table, to the left of the periodic table and below, it represents the metals. In this periodic table given to you, the metals are represented in red. To the right and above on the periodic table will be nonmetals, and they are represented in a bluish purple color. And between the metals and nonmetals will be our metalloids, or another name for them will be semimetals. Now, when we look at properties of certain elements, we separate them into metals, nonmetals, and semimetals. Metals are all solid except for mercury. They are shiny in color. They are ductile, which means they are able to be drawn into thin wires. They are malleable, which means they can be hammered or manipulated into flat sheets. All metals are good conductors of heat and electricity. They give off electrons during a reaction, and they have a high melting point. Now, with non-metals, they can be considered solid, liquids, or gases. They are considered to be brittle, which means they can break easily. They are dull in color. They are not ductile, which means they cannot be drawn into thin wires. They are not malleable, which means they cannot be hammered into flat sheets. They tend to be poor conductors of heat and electricity. They tend to gain electrons during reactions, and they have low melting points. Now, our semi-metals or metalloids are all solids. They can conduct electricity only when there is an increase in temperature. They can be ductile as well as malleable, and they tend to give electrons off during reactions. Some examples of metals, we have copper, lead, nickel, and steel. Some non-metals on our periodic table is sulfur, carbon, bromine, and oxygen. And 3 of our semi-metals that we can find on the periodic table is boron, silicon, and germanium. Now, some important information or terminology to remember to help understand the information we will further discuss are the following terms. The first one is an atom. An atom is considered the smallest building block of matter, and an atom cannot be broken down by chemical methods. Our next one is an element. Important to remember that an element is a substance made up of only one type of atom. Compounds can be considered to be 2 or more different atoms or elements that are chemically bonded with one another. An example is to form a new substance. When they bond together, a new substance will be able to be formed. A diatomic molecule, these are 2 of the same atoms which are bonded with one another in gaseous phase. There are only 7 diatomic molecules that are naturally bonded in a gaseous phase, which is hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. The image presented below under diatomic molecules is an oxygen diatomic molecule. As you can see there, a hydrogen molecule will consist of 2 atoms in gaseous phase that have bonded together. Remember, you must be able to identify the difference between the terminology that we have just discussed. So atoms are our single particles or our building blocks of matter. Molecules can either be molecules of elements or molecules of compounds. And compounds, it is the bonding of 2 or more atoms together to form a new substance. Something important to remember when we start discussing chemical reactions is the types of bonds that form during a chemical reaction. Starting with the first one over here, we have a metallic bond. A metallic bond occurs between 2 types of metals or 2 metals. The electrons, it forms a sea of electrons, and an example is copper. Our next type of bond is a covalent bond. And a covalent bond occurs between a non-metal and a non-metal that are bonding together. The electrons in a covalent bond are shared between the 2 elements that play a role in the compound. And an example can be carbon dioxide. Our last bond, which you must be able to identify, is an ionic bond. An ionic bond occurs between a metal and a non-metal, and the electrons are transferred during this chemical reaction. An example is sodium chloride. Now, when we start with this section, you must be able to name a compound given to you. There are certain steps which you need to follow. The first one is to write the name of each symbol found in the compound. Step 2 is to identify the bond that is present. Then, step 3, we have 2 specific rules. The first element's name does not change at all, but the second element ends with a suffix of IDE. If the bond is covalent, there is a 4th rule that comes into play. or a fourth step that comes into play. The second element will receive a prefix of either mono, di, or tri in this level of physical sciences. That prefix is determined by the number of atoms found in the second element in the compound. Let's have a look at how to name compounds. So we have given you two examples here. Let's start with carbon dioxide. Step 1 is to write the name of each compound, of each symbol. So we have carbon and we have oxygen. The ratio, to bring back some past knowledge, is 1 carbon is bonded to 2 oxygen. Step 2 is to identify the bond. Carbon is a non-metal and oxygen is a non-metal, so it is a covalent bond. Step 3, the first element does not change. So the first bit of our compound will be carbon. The second element gets an "ide." And the second element gets a prefix because there are 2 oxygens present. So example 1 for CO2, the name will be carbon dioxide. Our second example is NaCl. The common name for NaCl, which we'll discuss later on, is sodium chloride. Step 1 is to identify each element present. So we have sodium and we have chlorine. The ratio here is 1 sodium to 1 chlorine. Step 2 is to identify the bond. The bond we have here is an ionic bond. Step 3 is the first element's name does not change, so we keep it as sodium, and the second element ends in an "ide." So example 2 here will be sodium chloride. Remember, we do not add any prefix to the chloride because this is an ionic bond. The only time a prefix is added is in a covalent bond. So let's have a look at an example of naming covalent bonds. So the example is SO3. Step 1 is to identify what type of bond is present. This is a covalent bond because S is a nonmetal and O is a nonmetal. Step 2 is to give the names of the elements playing a role in this compound. The S represents sulfur and the O represents oxygen. Step 3 is to give the second element the suffix of "ide." So step 3 is sulfur oxide. And step 4 is to give the prefix. Remember, we are adding a prefix as there are 3 oxygen molecules present, so it is sulfur trioxide. If we have a look at a few examples of ionic compounds, we'll start with the first one, which is Fe2O3. Step 1 is to identify what type of bond is present. This is an ionic bond. Step 2 is to identify the elements that play a role in this compound. We have Fe, which represents iron, and we have O, which represents oxygen. Step 3 is to write out the name of the second element ending in "ide, and this is our final step. We are not adding a 3 or looking at the 3 or 2 at all in this example because it is an ionic compound. If we have a look at another ionic compound, an example here is KCl. Step 1 is to identify the bond, which is an ionic bond. Reason for that is because we have a metal bonding with a non-metal. Step 2 is to identify the elements that play a role in this compound, and it is potassium for K and chlorine for Cl. Step 3 is to give the second element the suffix of "ide, which gives us the results of potassium chloride. Now, there are certain compounds which we give a common name to, which means our naming rule does not apply to these certain compounds. The first one is water. If we were to make it a chemical name, it would be hydrogen oxide. But our common name for H2O is water. For the rest of the examples, as you can see, NH3, the common name will be ammonia. HCl is hydrogen chloride, but we know it as hydrochloric acid. H2SO4 is known as sulfuric acid, and HNO3 is known as nitric acid. Now we are going to do the reverse of what we have just done, and we are going to write the formula of a compound. First step that we will do is write down the symbols. The second step will be to identify the bond between the atoms that play a role in the compound. Step 3 is to identify what the valencies are of the elements, and that we can find on the periodic table. And step 4 is to cross over the valencies of the elements. Let's have a look at an example. Let's have a look at an example on how to write the compounds. So we have carbon dioxide. Step 1 is to write the symbols. We have C for carbon and we have O for oxygen. Step 2 is to identify the bond. This bond is a covalent bond. Reason for this is because carbon and oxygen are both non-metals and they have bonded. Now, step 3 is to determine the valency number of the atoms. Valency numbers will be above each group on the periodic table, starting with group 1 with +1, group 2 is +2, group 3 is +3, group 4 is plus or minus 4, group 5 is -3, group 6 is -2, and group 7 is -1 or -1. Group 8 has a valency of 0 as there are no outer electrons in the outermost energy level to be able to bond with other electrons for a chemical compound to occur or chemical reaction to occur. Remember, the transition metals, which is this block over here, will always be +2 except for iron, which is Fe, and silver and mercury, which is Ag, and Hg, which will have a valency of 1. So once you have identified where the valencies are, we place it with the chemical symbol in the top right-hand corner. So carbon has a valency of +4, oxygen has a valency of -2. Now step 4 is to cross over. So what we are going to do, we put the symbols next to each other, and the 2 of oxygen gets crossed over to carbon, and the 4 from carbon gets crossed over to oxygen. We simplify that, which gives us C1O2. Remember, the 1 can be omitted, which means left out, as it shows us there is only 1 carbon present and 2 oxygens. If we go to another example, which is sodium chloride, the common name of sodium chloride is table salt, which is normal salt that we would consume when cooking. So first step is to write the symbols down, which is Na and Cl. This is an ionic bond, which means it is the bond between a metal and a non-metal. Step 3 is to identify the valencies. So sodium over here has a valency of +1 and chlorine has a valency of -1. So again, the valencies get written in the top right corner of our elements. We cross them over, so the 1 of Na goes this side and the 1 of Cl goes that side. So our chemical formula is Na1Cl. You will see that we write it as NaCl, as the 1 does not have to be written in. It can be omitted, as we know if there is no number subscript underneath the elements, it means that there is just 1 that is represented. So let's have another look at an example. This one is with magnesium and magnesium chloride. So step 1 is to write out the elements that play a role in this compound. So step 1 is Mg and Cl. Step 2 is to identify the bond. This bond is an ionic bond, as magnesium is a metal and chlorine is a non-metal. Step 3 is to write out our elements and including their valency number. So magnesium has a valency number of +2 and chlorine has a valency number of -1. Step 4 is to rewrite our symbols with their valencies, and now we cross over. So the +2 of magnesium crosses over to chlorine, and the -1 of chlorine crosses over to magnesium. So our final answer will look like this: Mg1Cl2. Our last example involves lithium oxide. So again, step 1 is to identify the elements that play a role in this compound, which is Li and O. Step 2 is to identify the bond, which again is an ionic bond because lithium is a metal and oxygen is a non-metal. Step 3, write out the element names including their valencies. So Li has a valency of +1 and oxygen has a valency of -2. Step 3, rewrite the elements with their valencies so we can now cross over. Li with the +1 moves to oxygen and the -2 of oxygen moves to lithium. So our final product will be Li2O1. Thank you for coming to my lesson. We'll see you for the next lesson.